A valve cover. Cast iron, painted black, with the words "Power Stroke" stamped in raised letters across the top. That is the entire record. Ford Motor Company left for the man who wrote the check. No origin, no manufacturer, no engineering lineage going back to a company that had already collapsed once, rebuilt under a different name, and kept building diesels from the same Indianapolis plant floor for 28 consecutive years, while Ford put a different badge on every engine they shipped. The valve cover said Ford. The engine underneath it said something else entirely, and Ford arranged it so you would never think to ask. You already know the first half of this story. The 6.9-liter IDI, the 7.3-liter IDI, the dying International Harvester Corporation that handed Ford the most overbuilt diesel ever installed in a light-duty American pickup. A company negotiating with 225 creditor banks on the same day it signed a $500 million supply agreement. That story ended in 1994, when the mechanical era closed, the badging changed, and the diesel community assumed something fundamental had shifted. What almost no one knows is what actually replaced it. The same Indianapolis plant floor, the same engineering lineage, the same people who had been building diesels for Marine Corps cargo trucks since 1942, now operating under a new name after selling 150 years of American agricultural history to pay the debts a bad CEO ran up in 36 months. They didn't leave when the mechanical era ended. They built the next engine too. And this one ran in nearly 2 million Ford trucks across almost a decade before the relationship finally fell apart in a federal courthouse and a sealed settlement payment that neither company will discuss to this day. The name on the valve cover was never the answer. Subscribe to American Motor Files so you don't miss what comes next in this series. And drop your truck in the comments, model year, engine, and miles. We're building a record here. The engine that replaced the 7.3-liter indirect injection in mid-1994 is called the T444E. Navistar International's internal designation, turbocharged, 444 cubic inches, electronically controlled, that is what the letters mean. Ford called it the 7.3-liter Power Stroke, a brand name Navistar never used, attached to an engine Navistar designed in a plant Navistar operated with injection technology. Navistar co-developed under license from Caterpillar. 3 companies engineering under one Ford valve cover, one name on the outside. The T444E shares bore and stroke dimensions with the IDI it replaced, 4.11 inches by 4.18 inches, producing the same 444 cubic inches of displacement. That is where the continuity ends. The mechanical Stanadyne DB2 injection pump the IDI had relied on since 1983 was gone. The indirect combustion pre-chambers were gone. The naturally aspirated architecture that had made the IDI field serviceable with basic hand tools was gone. What took their place was a direct injection system no one had ever put in a light-duty American pickup truck before, running on technology that Caterpillar had spent most of the late 1980s developing for heavy commercial applications. Caterpillar called it the Hydraulically Actuated Electronic Unit Injector, HEUI. The system works by using the engine's own oil supply as a hydraulic medium. A high-pressure oil pump pressurizes the engine oil circuit to between 500 and 3,600 pounds per square inch, depending on load and operating demand. That pressurized oil actuates each fuel injector directly. A solenoid valve inside each injector opens in response to a signal from the engine management computer. The oil pressure drives the injector plunger. Fuel enters the combustion chamber at pressures up to 20,000 pounds per square inch. What that means in practice is this: fuel delivery is controlled entirely by software, independently of engine speed, independently of mechanical pump timing, independently of anything the previous generation of diesel injection had required a screwdriver and a warm afternoon to adjust. The IDI's Stanadyne pump was mechanical from one end to the other. A ranch mechanic could reach into the pump housing with a standard flat blade screwdriver and change the fuel delivery rate on the side of a dirt road in January. No laptop, no proprietary diagnostic interface, no dealer authorization. The man who owned the truck and the man who fixed the truck were understood to be the same man. Navistar and Caterpillar Co. developed the HEUI system jointly, with Caterpillar holding the primary patent. The T444E was its first application in any light-duty vehicle on the American market. An innovation that had been road-tested in commercial heavy-duty applications, Caterpillar's C-Series truck engines, Navistar's own DT466 medium-duty line, arrived in the F250 and F350 under a Ford badge with no announcement about where it came from or who had developed it. Ford called it the Power Stroke, stamped it on the valve cover, sold it to farmers, contractors, municipal fleet operators, and working men who trusted the name on the hood and had no particular reason to wonder what was underneath it. The Indianapolis plant ran 540 of these engines through the line every single day at peak production. Navistar's own commercial version of the T444E, the variant that ran in international medium-duty trucks, school buses, transit coaches, and refuse vehicles, is fully parts interchangeable with the 7.3-liter Power Stroke. The same iron block, the same cast iron heads, the same HEUI injectors, the same high-pressure oil pump, the same bore, the same stroke, the same compression ratio of 17.5 to 1. A diesel mechanic who rebuilt T444E engines in a school bus maintenance yard in 1998 and then took a job at a Ford dealership the following year was working on the same engine. He knew it the moment the valve cover came off. The font was different, the engine was not. The school bus driver in Gary, Indiana, did not know his morning route ran on the same block as the F350 pulling a grain trailer outside Laramie, Wyoming. The municipal fleet manager for a city refuse operation did not know his trucks shared injectors with the Super Duty at the Ford dealer across town. Ford did not mention it. There was no reason to. The badge was enough. Which part of that surprises you more? That it was the same engine across 3 entirely different markets, or that it ran under 2 different names for nearly a decade with almost no one connecting the record? The 7.3-liter Power Stroke ran from mid-1994 through the 2003 model year. In that time, nearly 2 million of them left the Indianapolis plant and entered Ford trucks across North America. The engine went through 3 distinct power calibrations: 210 horsepower and 425 pound-feet of torque at introduction, then 235 horsepower and 500 pound-feet beginning in 1998, then 250 horsepower with the automatic transmission and 275 horsepower with the manual transmission at the final 2000 upgrade. Each increase came from recalibrating the engine management computer. The hardware never changed. When a 7.3-liter Power Stroke from a 1996 F350 and a 7.3-liter Power Stroke from a 2002 Super Duty are placed side by side on an engine stand, the blocks are identical. The heads are identical. The injector architecture is identical. The difference between 210 horsepower and 275 horsepower lives entirely in the ECM calibration, which means the 1996 engine was always physically capable of delivering what the 2002 engine delivered. The Indianapolis plant did not build a better engine as the years advanced. They built the same engine, and Ford unlocked more of what it already was. The T444E in a 2001 International medium-duty truck, tuned for commercial fleet operation rather than consumer pickup duty, produced up to 620 pound-feet of torque from that same block. The Power Stroke version in a Ford pickup was calibrated to 525 pound-feet. General Motors' competing LB7 Duramax, introduced for the 2001 model year, was rated at 300 horsepower and 520 pound-feet of torque. The Duramax was a genuinely new engine, a 6.6-liter direct injection common rail design developed jointly with Isuzu. It made more horsepower than the Power Stroke in its first year. It also developed a documented injector failure problem that cost owners between $4,000 and $8,000 per repair event across the first 3 model years. The 7.3-liter Power Stroke had no equivalent failure mode. The restraint in its power calibration was intentional. These engines were not being pushed to their limits on the production line. They were being managed toward a specific kind of longevity, the kind measured in decades rather than depreciation schedules. With proper maintenance, a 7.3-liter Power Stroke runs reliably to 400,000 miles. The documented ceiling across owner communities sits above 500,000 miles. One forum verified report tracks original injectors surviving past 660,000 miles on a truck still in daily commercial use. The owner of that truck did not replace the injectors at 100,000 miles because no service interval required it. He replaced them when the engine told him to, at 660,000 miles, in the way engines communicate need when they are still capable of communicating at all. The injectors fire once per combustion stroke. Emission-compliant diesel injectors in trucks built after 2007 fire 5 or more times per stroke to satisfy particulate standards. A Cummins 6.7-liter injector, by one diesel technician's documented assessment, is worn to its service limit at approximately 120,000 miles. The difference in mechanical loading across 300,000 miles is not incremental, it is categorical. The 7.3-liter was not built for a world where injector replacement at 100,000 miles is considered routine maintenance. It was built for a world where the man who bought the truck expected to be the one who buried it. This is the last full production Ford diesel that assumed the man who owned it understood what he had. The HEUI system requires knowledge of oil pressure dynamics, not a factory scan tool and a dealer subscription. A qualified diesel mechanic with a pressure gauge and a working understanding of the high-pressure oil pump circuit can diagnose and address the system's primary failure modes without proprietary software. When the injector pressure regulator starts to fail, the symptom is a pressure reading outside specification. That is a number a mechanic can read with a basic gauge compared to the published specification and address without logging into a network. The injection timing is accessible. The fuel delivery parameters are readable. The engine does not report its operational condition to a remote server. It does not require a dealership to authorize a repair cycle. It does not derate itself at a predetermined interval while waiting for a technician to clear a protected code. The man who bought a 7.3-liter Power Stroke in 1997 bought a machine that trusted him to know what he was doing. The man who bought a Ford diesel in 2011 bought a machine that assumed he would bring it somewhere else when something went wrong. That transition did not happen because the engineering got better. It happened because the relationship ended, and the ending was not quiet. The Ford-Navistar supply agreement had run since 1981, 28 years. Every F-Series diesel from the 6.9-liter IDI through the 6.4-liter. Power Stroke left the same Indianapolis campus. Company names changed, executives changed, the engineering continuity did not. In January 2007, Ford filed a lawsuit against Navistar for $493 million. The stated grounds were exceptionally high repair rates and warranty costs due to quality problems attributable to Navistar, including design flaws. Ford claimed it had spent $1 billion on repairs and recalls for the 6.0-liter Power Stroke, the engine that replaced the 7.3-liter for the 2003 model year. Internal emails from John Kosevnik, Ford's director of North American diesel operations, documented warranty repair costs running as high as $5 million a month, and those emails dated to 2006, 4 years after the 6.0-liter had entered production. Ford knew. The service bulletins accumulated: EGR cooler failures, oil cooler clogging, head gasket failures, injector failures. These were not surprises to the engineering teams tracking warranty data in Dearborn. Navistar's response was immediate and surgical. On February 26, 2007, the company halted production and shipment of the 6.4-liter Power Stroke, the replacement engine Ford needed for its upcoming model year trucks. The Indianapolis plant stopped building engines for Ford. Assembly lines in Dearborn stopped moving. A diesel engine supplier had shut down a major American automaker's truck production. Navistar filed a countersuit. Ford alleged design flaws. Navistar alleged contract violations and claimed Ford was preparing to exit the supply relationship before the agreement expired. The litigation ran for 2 years. On January 13, 2009, both companies announced an out-of-court settlement. Ford paid Navistar an undisclosed amount. The exact figure has never been made public. The supply agreement ended on December 31, 2009. The relationship that had started in 1981 when a healthy Ford Motor Company signed a $500 million contract with a company negotiating with 225 creditor banks to avoid collapse, ended with a sealed payment and a corporate press release. Dan Ustian, Navistar's chairman and chief executive officer, stated that the two companies had benefited from a successful partnership that provided value to both companies for nearly 3 decades. 14 days after the settlement announcement, Navistar filed a separate document with the Securities and Exchange Commission. The company would close its Indianapolis engine plant effective July 31, 2009. Eric Tech, Navistar's vice president and general manager of the engine group, stated, "The significant change in Ford's business plans has forced us to make this decision." He added in the same filing that over the previous 30 years, Ford and Navistar dominated the diesel-powered, heavy-duty pickup truck market. The plant that had run since 1982, that had built the 6.9-liter IDI Farmers, bought without knowing who made it. That had built the T444E, which mechanics could diagnose without a laptop, and that had run 540 Power-Stroke engines through the line every day at peak, went idle on July 31, 2009. The UAW workers who remained accepted a 40% wage reduction in 2010 from $25 to $17 an hour in an attempt to reopen the Foundry operation. The Foundry closed permanently in 2015. The same floor where International Harvester engineers completed T444E prototype testing, while their company negotiated with 225 banks not to call in their loans, was silent before the decade ended. The men who took a pay cut to keep it open watched it close anyway. If you own a 7.3-liter Power Stroke, any year, 1994 through 2003, put the mileage in the comments, the full number. Because the record those engines are building has never been officially acknowledged by either company, and the people who know what they have are the only ones keeping it. Ford's 6.7-liter Power Stroke entered production in 2011. It was the first diesel engine Ford had designed entirely in-house since offering a diesel option in the F-Series in 1983. It was assembled at Ford's Chihuahua engine plant in Chihuahua, Mexico. By September 2013, the 500,000th unit had rolled off the line. It is a capable engine with documented longevity comparable to the 7.3-liter at sustained high mileage. It requires a factory scan tool to diagnose the injection system. It carries a diesel particulate filter, an exhaust gas recirculation system, and a selective catalytic reduction system requiring diesel exhaust fluid. It reports operational data through an onboard telematics architecture. At every design decision point, it assumes that the man who owns the truck will not be the one who fixes it. The valve cover still says Power Stroke. The assumption underneath it has not said the same thing since 2003. The Indianapolis plant, where the name on that valve cover was actually earned, has been closed for 16 years. The company that built what the badge promised has been renamed twice and absorbed into a European conglomerate. The workers who accepted a 40% pay cut to save the Foundry watched it close anyway. 2 million 7.3-liter Power Strokes are still out there. Some of them are running on original injectors. Some have been in continuous service since the Clinton administration. None of them know the plant that built them is gone. They just know how to run. The question the diesel community has never fully settled is whether the 6.0-liter disaster was a Navistar failure, a Ford failure in managing a supplier it had already decided to exit, or something both companies produced together when the relationship stopped working before either side admitted it. The timeline argues for all three. The engineering record of the 28 years before the 6.0-liter argues that the damage was done by the exit, not the partnership. That answer is worth arguing over in the comments. If this is the kind of record American Motor Files keeps, subscribe. There is more of it to pull.